Some time ago, my kids decided that they wanted to build a spaceship, and I volunteered to make the electronics part. So this is what I came up with. It's based on the $3 chalkboard that I got at some store. I drilled holes to put all the components in there and drew this spacey backdrop. The components are two strips of the WS2812, if I'm not mistaken, the individually addressable RGB LEDs, 12 in each strip, a yellow LED, an analog voltmeter, 0 to 5 volts, a key switch. Hidden here is a little light dependent resistor, and these two LED panels from an old elevator actually. This is controlled by this old joystick, which I got second hand. Someone hacked it before me and wired it up so that I can only read the two potentiometers of the left, right and front, back, but that's just fine because that's what I needed for this specific project. So I'll take the key here, put it in. You'll notice that when I switch it on, this is the fuel warning or fuel indicator, and this represents the amount of fuel in the tank. So when I operate it, you'll see that the tank is filling up. Here it is. And when the tank is full, we start our flight. We fly by moving the joystick. You see that when I push forward, we go into blue shift, and the further I push, the faster the LEDs go. This is the fastest setting. Now, unrealistically, the spaceship does not continue forward when I let go of the engines, but well, that's what you have. When you go back, you go into red shift, of course, and again, the speed is determined by the amount of pulling. When you go left and right, you'll see that the elevator LEDs also light up again as a function of the amount of twisting of the joystick. All this flying is taking up fuel, and you'll see that fuel actually goes down, and it goes down faster the faster you travel, or the harder your engines work. So let's skip ahead to when the fuel is about to run out. One moment. We are now approaching about 10% of the fuel tank, and I want to show you another thing. The LDR here is determining the amount of light from the LEDs according to the ambient light, so it doesn't blind you. If you're working in the dark, this won't be too bright. So you'll notice that this changes as I block the light. Now we go forward to about 10% of the fuel tank. Then this the yellow light will start blinking to warn us that we're about to run out of fuel. Here it comes. There it is. And when we are actually out of fuel in a few moments, everything will shut down. And this light will blink to remind us that we need to turn off the system and refuel, or actually restart. There we go. This does not respond anymore to the joystick, just blinking, waiting for us to restart. Now let's see what's in the back. To control the RGB LEDs, I used the Adafruit Arduino library, the NeoPixel library. So I just used an Arduino Nano, which was the simplest solution and the fastest. This should not be so bulge out like that. Anyway, the Arduino has only one control line that goes to both LED strips. That's why they're symmetrical. The whole thing is powered by 3 AA batteries, AA batteries, that go to this through the switch to this voltage regulator to 5 volts. These are the winkers, the side LEDs. Here's the capacitor and the resistors, which are recommended for operating the RGB LEDs. We have a common ground and common 5 volts for the components. The analog voltmeter. The yellow LED is here. The RGB is here. It acts as a voltage divider. That's why it has 3 wires. Everything is controlled by the little program that I wrote in the Arduino. Not too sophisticated. I'm sure you can do that yourself. But it was a quick project. Very nice. Kids loved it. And I'll put that in the spaceship now, so you can travel to space. Thank you for watching. See you next time.